Every single time you log into a website or buy something or just check your email, there's this silent, invisible process happening in the background. And it's all asking one really simple, fundamental question. We're talking about authentication, the unseen gatekeeper of your entire digital life. I mean, really think about it for a second. How does your bank, which might be hundreds of miles away, know that the person typing in your password is actually you and not just somebody pretending to be you? It's a huge question of trust, especially in a world that's basically built online. Okay, so let's get into it. This whole process of proving you are who you say you are, it's called endpoint authentication, and it's one of the absolute cornerstones of computer networking. Honestly, without it, our digital world just, well, it wouldn't be very secure, would it? Now, to really understand how this all works, we're not going to dive into a bunch of complicated code or anything like that. No, instead, we're going to tell a little story. It's a really simple tale that gets to the heart of the logic behind this whole thing. So, in the world of security and cryptography, there are these three classic characters that we pretty much always use to explain things. They just make it way easier to picture what's going on. So, let's meet our cast. First up, we have Alice. In our story, Alice is the sender. She's got a message, and she wants to make sure it gets to the right person, and only the right person. And this is Bob. He's on the other end, our receiver. He's waiting for Alice's message, but he needs to be absolutely sure that it's actually coming from her. And then there's Trudy. Trudy is the intruder. She's the one who's always trying to listen in on their conversation, or even worse, maybe try to impersonate one of them. Think of Trudy as any potential threat out there on the network. So what's the simplest possible way for Alice to prove who she is? Well, she could just send a message to Bob that says, "I am Alice." We'll call this our first attempt, Protocol 1.0. It's simple, it's direct, and it's really, really easy to break. Yeah, the problem here is pretty obvious, right? There's absolutely nothing stopping Trudy from sending her own message that also says, "I am Alice." So now Bob gets two messages, both claiming to be from Alice, and he has no idea which one is real. We've got to do better than that. Okay, so let's try something we're all familiar with. Let's add a password. A secret that only the real Alice and Bob are supposed to know. This seems like it should work, but Trudy, well, she's got a few tricks up her sleeve. So in this new version of our protocol, Alice sends her name, "I am Alice," but this time she also sends that shared secret password. The idea is that only the person who knows the secret can be the real Alice. That secret is what authenticates her. And hey, this probably looks pretty familiar, doesn't it? It's literally the same idea behind every single login screen you've ever seen. You put in your username, you put in your secret password, and that's how you prove you are who you say you are. But here's where it gets tricky. Remember Trudy? She's still out there, listening to everything. Now, she might not know what the password means, but she doesn't have to. She can just record the whole message that Alice sends, her name, the password, everything. And then later on, Trudy can just play that recording back to Bob. As far as Bob knows, he's getting the right name and the right password. He has no reason to doubt it's Alice. This little trick is called a replay attack, and it totally defeats our simple password system. So, you see, the real challenge isn't just about proving you know a secret. It's about proving that you're a live person, here and now, who knows the secret, and not just a recording from 5 minutes ago. And this is where the solution gets, well, it's pretty brilliant. This is the million-dollar question, isn't it? How can Bob be sure he's talking to the real, live Alice? He needs a way to ask her something that only the present Alice could possibly answer, something a recording couldn't predict. And the answer is this wonderfully simple idea called a nonce. A nonce is just a number. It's a random number that is only ever going to be used one single time. Its power is all in its newness, its freshness. So here's how it works in our final secure protocol. First, Alice says hi, "I am Alice." Then, Bob sends her a challenge, a brand new, totally random nonce. Now, Alice has to take that specific number, encrypt it using their shared secret password, and send it right back. Finally, Bob gets it, decrypts it, and if it matches the number he just sent out, he knows it's the real Alice live in that moment. And this is why Trudy's old recording is now totally useless, because Bob's challenge, that nonce, is different every single time. Trudy's recording has the answer to an old question, not the new one. Alice has finally proven not just her identity, but her presence. So, I know, the story about Alice, Bob, and Trudy might seem a little abstract, but what's so cool is that this exact challenge-response conversation is happening silently, billions of times a day, every single time you browse the internet. This whole process, it's a fundamental piece of the security protocols we use every day, called SSL and TLS. You know that little padlock icon you see up in your browser's address bar? That's your signal that this exact kind of secure handshake has happened. It's a hidden conversation confirming that your connection is safe. As we wrap up here, it's pretty amazing to just step back and appreciate how elegant that solution is. So often in technology, the biggest, most complicated problems are solved by these surprisingly simple, clever little ideas. The physicist Richard Feynman talked about this, about the gift of being able to see the simple truth hiding inside something complex. And really, the journey we just took, from a simple hello to a secure handshake using a nonce, is a perfect example of that. So maybe the next time you log in somewhere, you'll think about what's really going on behind the scenes. Just for a second, picture that quiet, clever handshake happening out of sight. A quick challenge and a response, all based on a simple one-time number, working to make sure that you are, in fact, really you.